Hey guys, welcome to Great Learning. Sensitivity analysis is such an important aspect of today's world where we use a lot of variables to perform data analysis, to perform various assessments and all of that, right? If you do not know what sensitivity analysis means, it actually plays a very important role in understanding what your variables do, and when multiple variables come together and you're using these variables to either assess or eventually to take it up to a point where you're going to be assessing it and producing a result out of it. Sensitivity analysis is key, especially in the domains of in the financial markets and whatnot. Sensitivity analysis sees a lot of hype, and in my opinion, it's not just the hype. The way the way the domain works, the way you look at data, handle data, and you realize that you can have multiple variables to have to give you multiple outcomes in many situations is something which is very important, and that's one of the reasons why sensitivity analysis is super popular today as well. So since sensitivity analysis is such an important aspect for you guys as learners to know, we here at Great Learning have come up with this course to make sure that you guys are solid with the foundations, and of course you can build up your arsenal on sensitivity analysis, and you can go about working with it and using everything you learn here to again devise your own applications and whatnot. Right guys? So my name is Anirudh Rao and I welcome you all. If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments. So to quickly talk to you about the course agenda, we're going to start this out by going right to the absolute basics to understand what sensitivity analysis even is. Because I'm sure that some of you all who might be watching this course may or may not have used sensitivity analysis, or you may or may not have even know about what it is, the nitty-gritty details exactly, right? So we're going to be diving right into that. We're going to cover everything right from the base up to a point to make sure that you guys know the topic, and after which we're going to be taking a look at the types of sensitivity analysis as well, because once you understand all of the basic concepts, you'll be curious to further build upon and go on and on to that. So as soon as we understand what the domain is, why we go about using it, we're going to quickly take a look at what are the various types of sensitivity analysis. And once we understand the various types, we are actually going to delve right into the heart of the topic to understand how sensitivity analysis even works. It's going to be a very interesting section, but after the section, I'm sure you might be left with one or two questions. To answer those questions, we're going to be comparing sensitivity analysis to another very similar entity called scenario analysis. So this becomes very important. It's going to it's one of these moments where you'll say, oh, okay, so this is how it works. It gives you a clarity about the entire thing and ensures that you do not confuse sensitivity analysis with respect to scenario analysis, right? So we're going to be discussing all of that, and after which, once we realize how it works, what are the various types and all of that, you'll be very curious to understand, okay, so where is this being used in real life around me? So we're going to be taking a look at some really important applications of sensitivity analysis. And after we discuss the applications, there'll be a thought in your head saying, so don't you think this may or may not work better for this domain or whatnot, right? So to further build upon the various applications we'll also discuss the key advantages and the disadvantages of using sensitivity analysis. Of course, the advantages outweigh the disadvantages by a large margin, but it is very important for you guys to know where sensitivity analysis is extremely good at, and there are one or two situations where it might not be performing really well. So we're going to be taking a look at that as well. And at the end, as you can see on your screen right now, we are going to be having a small practical demonstration in Python to showcase to you guys that whenever you can go about working with multiple variables, you can go on to see how easy it is to work with the topic at hand. Right, guys? With this, I hope the agenda is clear to all of you all. And on that note, we can get right into the first topic. Now, coming on to introduction to sensitivity analysis. Ladies and gentlemen, sensitivity analysis, when you say the term, it seems very complex, and to a certain extent, it is even slightly tongue twister, right? So, what is it? What are we talking about here? Well, basically, sensitivity analysis is a very popular tool that is that was made popular, in fact, by the financial modeling industry. Now, whenever you're trying to work on a solution, you might always know for a fact that you will have multiple variables and multiple columns and rows of data. You'll have a large amount of data that you will have to process, and you'll have to understand what each of those columns are doing to your final result, right? I'll give you a very simple example. Think about diabetes, right? Diabetes is a very common disease everywhere around the world, and there are many reasons of why there would be an onset of diabetes. Think about body mass index. Think about the age of the person. Even to a certain extent, it depends on your food habits, and a large extent, right? Your food habits, your diet, your exercise, and all of that, right? So there's many reasons, even blood pressure. So you see, if each of these columns were mapped out with respect to patients' data, at the end of the day, you can say which is the most harmful thing, which is which is causing diabetes, right? So maybe at the end of the day, your analysis tells you that, hey, maybe having a very high blood pressure is a definite cause for diabetes, right? So once you make statements like that, and of course it's all powered by data, it becomes super important for you to know that it's a very important assessment that you just made. You just figured out, of course we're talking about a hypothetical scenario here, but this is how it happens in the real world as well. You pick up a solution, you pick up a problem, you work towards the solution, you realize what individual contributions that are going into getting towards that solution, right? So the way we use this, the way we try to assess, the way we go about doing this is very important for you to understand. And in many cases, it so happens that you'll have multiple independent variables through which changing and doing anything to these will of course affect all the dependent variables out there. And working on these dependent variables, again, at the end of the day, you will know is not a piece of cake, right? So it's a very simple way of us trying to figure out what are some of these variables ways, and what are some of these various ways of how basically variables affect our final result. Now, I understand that whatever I might have said, can be a little complex for you guys to digest. So let me quickly simplify it with a beautiful example out here. Now, think about the situation about weather prediction, right? Now, we all take weather prediction for granted, I'm very sure. Now, if I ask you guys, what is tomorrow's weather going to be like? If you have to guess, you'll probably look outside and say, okay, this is the monsoon season, so it may rain tomorrow, right? It's a guess that you're trying to put up. But if you ask Alexa, if you ask Siri saying, hey Siri, what is the weather like tomorrow morning at 9 a.m.? There's a very good chance Siri is going to give you a very accurate answer, or something very close by to the actual thing, right? So you have to understand this. How does Siri know what the weather will be like tomorrow morning, right? And that too extremely accurately. I am sure you've been in a situation where you're confused if you want to take an umbrella out or you want to take a cab out on your weekend or something. And that is when you say, hey, let me check the weather quickly. And then you try to figure out what's going on with the weather, and you have a perfect answer, right? Maybe you're planning your Saturday evening plans, and it's the Saturday morning right now. You and your friends are planning up, and what you eventually do is you say, hey, let me check out what the weather is like, and then try to see if I can come on my bike, or if I can, take a cab over there. So you're trying to assess, and you're going to ask Siri or Apple, Alexa, whatever it is. You're going to ask these Google Assistant or anything, any of these entities to say, predict what the weather is going to be like. They do it very accurately, and you can plan your day accordingly, right? So this situation that you're involved in uses a lot of sensitivity analysis, uses a ton of machine learning and more. Now, an important thing you have to understand here is that when you're trying to assess what the weather is going to be like, you have to be very critical at the end of the day, because the weather that you're talking about depends on so many different things, right? There's things such as precipitation, things such as humidity. Pollution is also a huge factor in understanding what the weather is going to be like, right? So each of these factors have a say. They have a play to to have an influence on the weather, on the next day, tomorrow's weather, today's weather, whatnot. So understanding which of these will have the most impact on a diverse change in weather, right? Of course, we're living in a period where there's a lot of advocacy going on for global warming, and people are trying to look towards the electric vehicle revolution and whatnot, and they're trying to understand this, maybe because they figured out that we are polluting, and of course not that maybe we are polluting a lot collectively as a species, and at the end of the day we're trying to understand how it adversely is affecting the environment around us. And I'm very sure if you open up the news right now by pausing this video, you can see that there are some things going on, right? So quickly, to give you a gist about it, that's all it is, right? So we're trying to use multiple factors to get to understanding what the weather is like, and each of these factors can have a very, very important role in that, right? Now, one important thing you have to really know is that sensitivity analysis is mainly used as a tool which is eventually going to help us about having multiple sources of uncertainty, right? How do they either positively contribute to your whatever analysis you're doing, or do they negatively contribute to your forecasting as well, right? Now, if you have very less pollution, it might mean that you get more rain, right? So less pollution, more rain, more pollution, less rain. Think about something like that, right? That's a negative correlation. Now, when you have a positive correlation, it should mean something like if your humidity is very high, it is going to rain. High humidity, high rain, right? It's both are increasing at the same time. Now, that is very important for you to know, because this concept, whatever that I just said, right? Understanding how your variables either positively or negatively affect the outcome or contributing to the overall forecasting. This basically, the feature is going to give us a wide array of domains. Right now, you might just think saying, hey, if sensitivity analysis is all about weather predictions, what are we even doing? No, it's not all about weather predictions. The way you approach the concepts and work, you can use it in any other domain, even in a domain such as healthcare, where sensitivity analysis is very important in many, many cases, right? Now, to give you a little bit more about, give you a little more insight about sensitivity analysis, one thing where it really is popular and where it really shines is when you're performing model designing, right? Now, whenever we're working with machine learning, a domain such as machine learning, it becomes very important to where, 90% of your solutions usually start out as a trial and error. You want to understand how your models will go. That's how you usually, on your first attempt, you build your models, right? So in that process of experimental model design, you will get to understand, what parameters you have to play with will have what sort of an effect on the result. Now, you can tweak and tune one or two columns worth of data, and you will realize that your machine learning model can go from a very bad state of accuracy, somewhere around 60% accuracy, let's just say, to somewhere around 95% accuracy, right? Just because you know what parameters to vary, and it's not like it's a thought in your head, and you can figure all of this out through data, through statistics, through hard proof, to say that this is how much of, we have a concept called correlation, right? This is how much a relation that exists between these variables. This is the amount of interdependency that exists between variables. And you will know that what happens if you change one or two of these variables, or one or two columns worth of data, or even a more technical term is features. So what happens when you change certain features, and how does your change of those features affect your solution? Are they positively helping your solution, or are they negatively affecting your solution? Think about it, right? It's very simple. Any example that you can think of, you pretty much would have thought about it the same way in real life, but you might not know that we call it as sensitivity analysis here in the domain, right? So knowing that it helps really well in experimental design is critical. Understanding that it will tell you which parameter you might have to vary to have an effect on the solution, and you will know how to work with your variables better. So your perception of your data can be better as well. That's an advantage. And understanding what changes will get you to observe those changes on the objective function is also very, very important, right? So these are the really important things you guys should know. Now, in the next section, now that we understood the basics of sensitivity analysis, we're going to try to understand the various types of sensitivity analysis that are out there. In fact, there are two major types of sensitivity analysis. It's local sensitivity analysis and it is global sensitivity analysis. Pretty easy to remember this, right? Now, when we say local sensitivity analysis, what we're trying to basically mean, the term local, right? It refers to the fact that wherever we are trying to perform sensitivity analysis, analysis, the derivatives are calculated in that moment at that particular location. We are not trying to bring values from some other place, and we're not trying to create multiple paths through which, or channels through which we're trying to bring in data, funnel in data, and then perform analysis. No, here your data is already there, it is ready, and through the simple way of you actually calculating derivatives at the moment will give you an upper hand in this strategy. Because wherever we are trying to understand with machine learning, I'm very sure you're familiar with the concept of what a cost function is, right? So this strategy will work really, really well for a cost function. But that is where the advantage sort of tends to trickle out, because at the end of the day, it does not become practical when you have extremely complex models where your data is not seen as continuous as it could be, and wherever you cannot necessarily create these derivatives, wherever you can have derivatives, that is when it becomes slightly difficult for sensitivity analysis, especially local sensitivity analysis, right? So this is really important for you guys to know. But then what is global sensitivity analysis? Well, global sensitivity analysis is the second method through which we're going to be performing sensitivity analysis. Here, mostly we consider this as a foundation, as a pillar, or as a very critical part of these Monte Carlo methods. I'm very sure you might have heard of Monte Carlo methods, right? Now, wherever we're trying to have a situation where explore the design space by making use of a large number of samples, these large number of samples occurring from multiple places, and you having to perform analysis on all of them and eventually getting to the result through global sensitivity analysis using these Monte Carlo methods, it actually takes a very, very complex process, simplifies it down, it almost dials it down to a very simple level to make sure that at the end of the day you can work seamlessly with not just a large amount of data, but you can also find easy ways to tweak not so high quality data, right? We already know that machine learning depends not just on the quantity of data, but it is also very, very critical on what? On the quality of the data as well, right? So that becomes very important for you to know. Now, one important thing you have to also know here is that whenever we try to have independent variables, whenever we have dependent variables, whenever we have this relationship that exists between these variables, it's called as correlation analysis. Now, I used the term correlation a while back, right? Correlation basically talks about how two variables are complementing each other, or how two variables can either work together or work against each other to eventually get you to your objective function, right? So taking, applying a function on these variables and working with it, you might have heard of the term regression or regression analysis. Regression analysis is really, really popular in terms of sensitivity analysis as well. Now, one important thing you really have to know about sensitivity analysis, or another key part of it, which is subjective sensitivity analysis, it basically talks about how you have individual parameters that are being assessed and analyzed, not just on just brushing over these variables and saying this might have some sort of an effect on your outcome, but we're trying to analyze it and assess it in high amounts of depth. Let's just say in depth at the end of the day, because without doing any of that, you will not have any clarity, which we're talking about right now, right? We can use various simple qualitative methods to actually understand how you can, remove certain input parameters. If you think that it's adversely affecting the solution, maybe add a couple of columns, do some sort of feature engineering to bring in more data, if at the end of the day it will help your objective function, right? So this becomes important for you guys to know. Well, with this, I'm very sure you guys must be very clear about understanding what sensitivity analysis is, where it is used, and a certain bit about understanding local sensitivity analysis and global sensitivity analysis, right? So with that, we can quickly move to the section of checking about how, sensitivity analysis even works. Now, sensitivity analysis actually was made really popular by financial analysts. Now, it was a tool. It was almost sort of a secretive tool that these guys were using to understand what happens, when you perform in-depth analysis in the financial industry, right? We know the humdums of the financial industry where, almost everything could be as secretive as it's called. So basically here, sensitivity analysis is also called as simulation analysis, or in the common layman term, if you ever hear anyone saying what if analysis, as in what happens if this happens, right? So when you are talking about that conditional approach to knowing that, again, the same story about your variables and your outcome, it is very, very important. Now, where is this used in the financial industry? Well, it is actually used to understand how the interest rates, right, affect one share or the other share, or maybe a bond or anything like that. And once these numbers start to come up, you can actually make predictions about it if you have a lot of data to say, hey, maybe, the shares you're talking about, the stocks, the bonds or something, you will figure out that maybe it has a higher return rate than you expected initially. Or if it's an adverse solution, which no one likes to hear, is that it might have a very low return rate than your initial expectation, right? So this is very important for you to know. Now, one advantage when it comes to sensitivity analysis is for the fact that it will allow you to perform in-depth analysis, assess not just brush over these variables as I just mentioned, but understand which variables has a lot of say in the final result, right? Now, as I gave you the diabetes example, unless you perform analysis on thousands and thousands of patients, you cannot guess. Until that point, everything will be a guess, right? Now, you might say, hey, diet is the most important thing to make sure that we don't, to make sure that you can prevent diabetes. But another expert might say, hey, I have ran through all the data. I've maybe ran through 10,000 patients worth of data. I've performed predictions on it. Now, my model tells me that the most important part about you not getting diabetes is to make sure you control your body mass index, or maybe you controlling your blood pressure or something like that, as I just told you, right? You will figure out which is the most important variable. And once you figure that out, especially in a real world solution, let me tell you, I've built multiple products to date. And in that moment of time, you will figure out what is important, and your connection with your data goes really high. And once your connection is like really good with your data, and you know what variables has what say on the result, trust me, you will find, I don't want to say shortcut, but I want to say that you will find the fastest paced path to ensuring that you have really high accurate results in machine learning models. And of course, who doesn't want that, right? Because now, in the financial industry, with the power of machine learning and AI, you can actually tell investors to say, hey, look, this particular investment that you're trying to make might, not pay off fruitfully because of so and so variables, so and so factors. And the other way around as well, right? So maybe you can bring in more investors, and you can tell them, hey, using our tool, you can figure out what happens when, what you can expect basically of the market. No one can ever exactly say what's going to happen in the market, but you can give them a very good data-backed solution, a data-backed answer to tell them, there are certain variables which might affect their investment returns either in a good way or in a very bad way. And if you are on the other side, of that discussion, where you're trying to understand what's going to happen to your investment returns, guess what? You'll be a very happy man or a woman knowing that you're not just throwing your money at something. It's not a black box that you're throwing your money in, but now you have complete clarity about what goes on in the back end as well, right? So the advantage again beams on the fact that you're performing predictions based on all previous data and the current data that you have at hand. And in today's world, by the time you heard that sound, we have terabytes worth of data that is generated, right? Now, again, I just snapped my finger again. Oh, I love that sound, right? So I snapped my finger again, and by the time you heard it the second time, I assure you, I promise you that all of our hard disks, each and every one of you all watching the course, including me, our hard disk would have been full 10 times over. That is the amount of data that we are generating in today's world, right? So think about the commercial applications, think about the use in the world of economics, and the part of the financial analysis is always going to take center stage, because that is where it found its I want to say it found its reckoning, and eventually that's where its popularity comes from. And that's where we figured out saying you can use this sort of analysis in other domains, and turns out it's been doing really great as well, right? Now, to help you understand how sensitivity analysis works even in another step of detail, I want to give you a small example. Now, let's consider a hypothetical example of a person who is the head of sales at a winter wear company, right? Let's just say her name is Linda. Now, Linda is the head of sales at a winter wear company. Now, winter wear company, if you do not know, as you can probably already guess, is a company that sells you winter goods. Now, what are winter goods? It can be it can be all these important things such as fur jackets. It can be gloves. It can be your padded jackets, it can be insulation, thermal gear, it can be mufflers, whatnot, right? Scarves, everything to make sure that you don't feel really cold when you go out into the cold, right? Sub-zero temperatures, freezing temperatures. Now, what Linda and her company, is that they sell everything. You want raincoats, you get it there. You want jackets, you get there. Even extreme winter wear, right? Now, I myself have a jacket which is rated up to minus 30 degrees Celsius. 30, right? That's a very thick jacket where, if it's probably a snowstorm, I can sit in the snowstorm, and if I'm all covered up, I can be warm, right? So let's just say I bought it from Linda, okay? Now, what she does is Linda knows for a fact that her sales usually happen in the winter months, right? In India, where of course I live, the winter months are usually somewhere around November, December, January. Now, here is where in the northern part of India, in the Himalayas, it snows a lot, and eventually this is where people would want to buy more of these winter clothes. Now, if it is peak summer where there's no snow, nor does the temperature go to 0 or -5, -10, wherever her products work, if it does not go in the summer months, would you want to buy, right? Think about it. It's almost the same situation where you would want an air conditioner for the summer months, but it wouldn't make sense if you had an air conditioner. You want to say, hey, it's winter, I'm going to cool even further down. Would it work? Absolutely not, right? So Linda knows. Linda is a person in a good state of mind. She understands that her sales only happen in the winter months. And now what she wants to know is that last year she has all the data to tell her that, hey, last winter season, I sold so many goods. Now this winter season, she wants to understand what will be the rise in sales that she has got from the previous year, right? So to give you, let's just go further into the example here. In the example, let's just say one single jacket costs somewhere around $300, and I think that's what I paid for my highly rated jacket there. So let's just say that during this particular season, $300 is what one jacket costs, and last season Linda sold 100 of these, so eventually that took her sales of somewhere around $30,000. Now what Linda does, she uses sensitivity analysis to understand if she will get a slightly increased customer walk-in in summer, because she's been seeing patterns where her sales are not completely zero in summer. Her sales are still there, and every summer it is increasing slightly. It's going one more step. So she definitely wants to understand, hey, there is a rise in summer months as well. Now I want to sit and analyze in depth to see how much of an increase that I'm going to get on all my winter goods there, right? So with all this information at hand, she can accurately predict how much revenue she's actually making from different customers at different months. She can pick up all the customer data from summers, she can pick up all the customer data from winters, and she can come to a conclusion after performing analysis that says, hey, last summer season, instead of selling, she sold 100 jackets in the winter season, let's just say, and in the summer season, let's just say, she sold somewhere around 20 jackets. Now, her analysis might say, hey, instead of just buying 20 jackets to sell to your customers this time, why don't you buy 35 or 40? Because this summer season, you might see a lot more customers walk in. And if that doesn't work, you can put it to storage and eventually sell it in the winter months as well. But she wants to be ready for those customers who walk into the summer, right? Now, there are many shops around the world, ski shops and whatnot, where if the season changes, if it's summer and if there's no snow on the mountain, the shop's completely shut because you can't ski on a mountain with no snow, right? So she wants to understand, she wants to be prepared to serve her customers even in a month where people might not, even in a period of the calendar month where people might not use the goods. And now she has a conclusion to say, even the most adverse case, she understands that she can make money, and she's figuring out how much to stock up to help out her clients, right? Now think about this for a second. I gave you a blown up example of a very simple situation. This, if you increase its complexity by probably 1,000 times, this is exactly what happens in the real world around you. Every single company, not just winter wear, even probably the companies who manufacture food, every industry who's performing analysis has probably used sensitivity analysis in the past, so they're using it as we speak, because it will give you a solid way of not just guessing what might happen, but it'll give you a solid way to tell you, hey, here is data to just prove everything that I have said. And when you're trying to pitch it to your manager, when you're pitching it to your client, or when you're proposing it as a solution to someone, when you say, I have data to prove everything I say, I'm very sure everyone would be interested to listen to that, right? So that is really important for you guys to know. Now, with that, we'll actually have to come to a quick section where we'll have to take a look at understanding something called scenario analysis as well. Now, sensitivity analysis and scenario analysis are usually confused often, by beginners and people who are getting new into the domain. So, to give you clarity on it, let's quickly take an understanding of what's happening. I'm going to give you another example, right? Now, scenario analysis is basically something that you would be using. It's frequently used to investigate certain situations, certain niche situations into a very, very, very good amount of depth. Think about a stock market crash, right? When a stock market crash happens, everyone is panicking for a while, but after that, people will sit and analyze every single point to maximum depth to figure out why the market crashed at that moment of time, right? So analyzing this and understanding that what variables in the model will fit all the details for any specific use case, and to just use that learning to understand that, hey, now this might have messed up the entire stock, or this might have messed up a rally, an upper circuit, a lower circuit or something, and eventually that might have led to some other collateral damage, and that just led to a crash as well, right? Now I just gave you a hypothetical example, but that happens when you use scenario analysis, right? So it'll basically give you an entire spectrum of outcome to be viewed at any extreme you want. All the bad extremes where you know that market is going to crash, or any good extent where people are saying that the market is going to crash, but your scenario analysis at the end of the day is saying, no, it will not crash, do not worry. Right now, we have had we've had very good movies with very famous actors wherein they have portrayed what happens when you when you go about playing with the market, and in many languages as well. I'm sure if you guys are movie buffs, you will understand all these crazy stock market movies. And there, trust me, there is manual analysis going on, because when you take a look at the stock market crash in the early 21st century, people did not really have a lot of machine learning to do. They just had a ton of data through which they had to manually process. But the process is almost similar, because here too they're trying to achieve the same outcome, right? So you're not just getting a clarity about what single variable has what sort of outcome, but here you'll have a complete grasp about what happens when you not just bring one variable, but a huge combination of variables which can completely do its own thing, and understanding in a real life situation what would happen if these variables were used. That is where this quick understanding of what happens in terms of sensitivity analysis and what happens in terms of scenario analysis comes to the picture, right? So that's very important for you guys to know. Now, with that, we can actually take a look at the next section, a very important section where we're going to be understanding some of the key applications of sensitivity analysis. Now, ladies and gentlemen, it will actually become very difficult for me to sit and tell you every single application out there, because we have thousands. I'll be very honest with you, right? So overall, what we're trying to do here is that the main purpose for us is to make sure that we're trying to understand what sort of, basically we're trying to understand the sensitivity of the simulation, where we're trying to understand what is the uncertainty. We're trying to predict something that's uncertain in the model's input data, and we use it to make sure that at the end of the day, if you want to make some decisions and you want to have some data backing, data-driven conclusions. When I say data-driven conclusion, it basically means that you came to that conclusion because you had data to support a certain hypothesis or to support a certain thing that you might have been thinking of, right? So what sensitivity analysis does is it is giving you this strategy to forecast how well a decision is used. And again, all of these applications that we're trying to discuss, right, wherever you talk about it in whatever domain, either of these is going to work really, really well for you, right? So wherever you want to understand that, hey, I have multiple strategies to a problem solution, you can get confused to say, which strategy do I pick? So basically, sensitivity analysis will tell you the amount of risk that each strategy poses. So you can, you can either be very comfortable maybe with 20% risk, or you want to be a little adventurous to say, hey, even though, this is, my model is telling me that there is 80% risk here, maybe I want to invest, right? Maybe it is giving you a very high risk, high reward ratio, right? So all of those things happen. Now, whenever you are trying to understand how reliable is your output based on how does it change based on one single input value, we have seen this in machine learning. If you guys have performed feature engineering in machine learning, and if you have worked with it to a good amount of detail where you're working on your data set and your model at the same time, it is very, very intriguing for us to know that one or two very small changes in your data set, in your very large data set, which might seem very inconsequential, at the end of the day will either completely tank your model's accuracy, or it's going to bring it up to the 90s, right? So that is very important for you to know. And with this, you get to have clarity about why, how, and when that happened as well, right?
So in many real world situations where you want to understand that there is a lot of danger that is involved, maybe firefighting is a very good example, right? So understanding what will help you to safely reduce your risk and to make sure that the danger will not get to you at the moment is also something that can be done. And in any form, any domain, any single application that you try to devise, sensitivity analysis can be made to fit in. That's the advantage, and that it will help you make really well informed and appropriate choices at the end of the day, right? So it's not all the good bits that we're trying to hunt here as well. Even whenever you have a model which might not be performing well, the reverse of the situation also works. If your model is not performing well and you want to understand why your model is not performing as well as you would have probably expected it to, you can use sensitivity analysis to go back to assess each variable, what's happening where, and eventually come to the solution again, right? So this becomes very important for you to know. Now, if you want to directly relate to a certain example of all these key applications that I gave you, right, this is how sensitivity analysis fits in an application for any domain. Now, those couple of points I told you works for almost all the domains out there. But if you require, as an example where you can relate directly to, think about the climate model, think about weather forecasting as we already discussed. And whenever there is a situation where someone has to work with something like differential equations, that's a world of its own in mathematics, right? I absolutely love differential equations. And whenever you have to perform scientific research on that, sensitivity analysis works great as well, because you get to know what each of the variables are doing and how they might behave differently as well, right? Now, it works really well in a feedback loop as well. Maybe you have already sold a product and now you want to understand, how your product is performing and eventually create a product, right? So whenever anyone rolls out a product in the market, they want to make sure it never fails. But some products do fail. So where does your point of failure lie in? That is critical for us to understand, right? So whenever those sort of analysis, everything from selling a pen where, the lead in the pen could keep breaking, all the way to understanding why a space shuttle might fail. What are the reasons to understand that, these are the reasons that the space shuttle might fail. So you'll have to fix up certain things to make sure it doesn't happen. See, from a pen to a spaceship, sensitivity analysis can be used everywhere, right? Fantastic. Now with that, we can quickly take a look at understanding what are the various advantages and small amount of disadvantages of sensitivity analysis. Now, ladies and gentlemen, when we talk about advantages and disadvantages, let us get away with the advantages first, and later we can pick up on the disadvantages, right? Now, whenever you're making predictions, basically, there's two ways to go about it, in my opinion. One is you can actually accurately predict by making use of data, or the other thing is you can just guess. You can say, hey, tomorrow it'll rain. You will never know if it'll rain or not because I just guessed it. I have no idea if it'll rain or not. But if I tell you, hey, tomorrow it'll rain because the precipitation is so and so, the wind direction is so and so, the cloud cover is like this, the clouds are moving towards. So if I give you some sort of data to prove what I'm saying, that will make more sense, right? You can do that with sensitivity analysis, as you've already figured out. Now, the other capability is that it will also allow these critical decision makers, right? Sometimes one single decision can make or break a business. And if it's a decision that important, you don't want to leave it to chance. You don't want to say, I will guess, right? You want to make sure that you are very accurate in terms of there. So in any domain, again, at the end of the day, if you have to make an informed decision based on multiple businesses, based on how the economy might go on, or based on your investments that you would have made, guess what? It is helping decision makers do all of this in a very important manner, right? So this is very important for all of you all to know. But it's not always bells and whistles. There are certain disadvantages you also have to know about. In fact, too, one important thing is that whenever you're trying to predict something in the future, you're using historical data, right? You are not actually predicting the future. You're just saying, hey, I have all the data to show that this might happen. You might attach probability to it. You might say there's 80% chance that this might happen, but rarely we ever say there's 100% chance of something happening, right? So in many cases where there is no room for any sort of error, historical data, no matter what level of analysis you can do, it is very difficult to actually put a direct map, to put a direct point and say this variable might have a say in that, right? On the whole, if you have an extremely large data set and you have a tunnel vision to focus on a small amount of things, maybe yes, changing a small thing can have a very good effect on the overall outcome, but that might also be happening from something else, some other data point, and for you it is very difficult to track when when you have a very, very, very complex data set, right? So again, for example, let's go back to Linda. Linda might not sell as many jackets or winter clothes in this particular year, right? There might be many other reasons for it. When you add sensitivity analysis to it, you cannot predict what your competitor is doing. Now, Linda can assess all her past data and maybe even all her past competitors' data as well. But at the end of the day, if Linda starts selling and she has already performed analysis, she knows that she has to buy 20 jackets, but there's a competitor next door who says, hey, I'm going to give you 40% lesser price than what Linda is paying. Now, even though she performed a lot of analysis, where do you think the customers are going to go? They're going to go to the competitor, right? Now, Linda cannot use that to sort of make assessments in hand, in time. Of course, later she can use the competitor's data to eventually, go about saying, okay, so competitor is giving 30% discount maybe, so let me also match that by providing 30%, or let me throw in a buy one, get one offer, something like that, right? She can do it after it happens. She cannot do it before it happens. She can maybe account for it, but at the end of the day, her way of assessing it can also be very different. She might think that, hey, competitor might not give more than 10% discount because it might not work out for them. But the competitor swings in at a wholesale price and says 40% off for everyone. That will take Linda back, confuse her, even though she performed analysis, right? This is where one or two sensitivity. It's very situational. It's very niche, but it happens, and it's just the way it is, right? You're going to use that later, but whatever the competitor did this year, she can definitely use that to make sure she's matching or beating all the offers the next season around as well. So that is critical for all of you all to know. Well, with this, we've understood a lot about the theory of sensitivity analysis. We understood local sensitivity analysis, global sensitivity analysis. We understood how it works, where it is used, key applications, advantages and disadvantages. We took a look at a lot of things. Right now, let me actually take you over to Google Colab, which is nothing but a simple Jupyter notebook that is hosted on the Google Cloud platform, where I'll show you a very, very simple, very small demonstration to tell you and showcase to you about what happens when you start working with a data set and the changes in one mapped onto the other, right? So we're going to be using a very small example. The goal here is to not walk you through what each of the line in Python does. If you're watching this video, I'm very sure you must have had an introduction to understanding Python syntax and knowing a bit of machine learning as well. So the goal there is for you to analyze how easy it is for you to perform sensitivity analysis right from the first step, where you probably import all the libraries, all the way to you punching out the accuracy, the final results and whatnot, right? So let me quickly open up Colab and we can get started. All right, guys. So as you can see, I've quickly opened up Google Colab. Now you can use the same code, and you can actually, it doesn't have to mean that this code only works on Google Colab. You can actually type it out on any of your Jupyter notebooks or any other IDE that you might be using, like PyChar or whatnot, and you can work with the same as well, right? Now, let us actually try to understand what we're going to be doing while we are doing it. Now, the first step in any sort of demonstration or whenever you're trying to attack a use case is, what do? We try to import all the libraries that we want to use, right? Now, of course, there's going to be one or two imports later as well. But for now, since you're working with a lot of data, we need NumPy. NumPy basically is a fantastic library, numerical Python, which is used for numerical calculations and activities. We have Pandas. Pandas provides us with two beautiful data structures, Pandas series and Pandas data frame. In fact, we're going to be using, as you can see, we're going to be actually using Pandas to read in our data set as well. Matplotlib is a beautiful library for performing data visualization. I'm sure you would have already known that, right? Now, I'm going to hit play here on the next line where we're actually trying to import the data set. It's going to actually throw me an error. It's going to tell me, hey, you're trying to use the Google Cloud platform, but where is the data that you're asking to import? What I'm going to do is I am going to quickly import all the data. I'm going to hit OK. This yellow circle that you see, as soon as it's finished circling, our data set is imported. I'm going to close that. I'm going to hit run again, and now you'll not be as confused because it says what's happening, right? Now, let me explain what we're doing first of all. Here, this is, as I told you, right? Sensitivity analysis works great, especially on the product, on the sales side of things. Now, here, what we're trying to do is we're trying to understand, a lot of things. For example, the gender, the age, the estimated salary, and purchased. So you might be a little confused. So whenever you're trying to purchase a product, maybe let's just say it's a mobile phone, right? Now there's various types of mobile phones. Maybe it ranges somewhere around 5,000 Indian rupees, and it goes all the way to all these extremely expensive phones which cross 1 lakh rupees, and they're again very popular and they sell really well as well, right? Now, It's not that everyone can go on to afford the most expensive phone on the market, and people who have really high salaries might not want to invest in a very, very low end mobile. There are exceptions, yes, but that's how it is, right? If you're probably making a couple of crores a month, I don't think spending 1 lakh on a phone should hurt you at all, right? So what we're trying to do is a product company says, hey, I want to understand at what salary bracket and at what age are my customers at. So what age customers am I getting who are actually buying my products? And if they're buying my products, what is their approximate salary? Because with that, you can perform analysis to tell that, hey, people in this salary bracket are, very popular for buying my product, but people in the, maybe in a smaller salary bracket are not probably very keen on buying your product. Maybe later you can use that result to actually assess and analyze how much of an impact age has on your product, right? Now, there are certain items which will sell really well, regardless if you're rich or poor, at the end of the day, to maybe a very young audience, right? Now, a very good example is that ring light that you would have seen where people make selfie videos for very popular apps and whatnot, right? Even though it might be either very cheap or very expensive, it doesn't matter. People of a certain age group are going to buy it no matter what. There's this fandom, there's this craze. You can analyze and assess all of that as well, right? So basically, user ID you can ignore. It's just each individual user. I've just printed out the first 5 rows of data for you. We have the gender of the person who has either bought the product or not, age of the person, estimated salary, and if the person purchased their product or not. Now, all these cases say 0 because these people and these data, they have not purchased the product. But we have an entire data set where they have. This is just the 5 rows that I've printed for you. Now, what I'm going to do is right now, I don't want to say if male population bought it or female population bought it, and I don't really want to know about a particular user. So I'm going to remove user ID, I'm going to remove gender. I'm just going to have age and estimated salary to perform predictions, right? Purchased is our objective function. As you can see here, we're trying to split out the columns, we're trying to filter out, and all we're trying to have remaining is these 3: age, estimated salary, and purchased. But the purchase part is what we want our algorithm to predict. So we're going to remove that and keep it separate. As you can probably see in the second line here, I'm going to hit play. Our data set is filtered out now. We don't have user ID. We don't really care about the gender anymore. Age and estimated salary is what we have at hand. Now, with any machine learning solution, what is it that we do, which is very critical? We take the data, we split the data out into testing data set and training data set. Training data set is what is used by the algorithm to completely learn, and later we surprise it with a testing data set with the data it has never seen before to predict if it can work really well or not, right? Because if you use the training data to train, and if you later provide the training data again, it knows everything. It's going to say 100%, right? It's like you sitting in your college while you're writing an examination, someone says, hey, here's a textbook, write your examination. You don't have to remember anything. You don't have to learn anything. You can just copy and paste it and you're done. You can get 100 out of 100, right? Not that I'm advocating you guys do that. Don't do that. But yeah, that is how it is, right? So to make sure that you're actually surprised, you will be familiar with the concept of your college giving you textbook and later giving you an examination. So to give that examination, we're keeping data aside right now. The next step is very simple. We have to scale the data out to a normal distribution. So whenever you have a large amount of data, to perform analysis, you have to bring it to a certain range. You have to normalize the data to make sure that your machine learning algorithm has an understanding of how far away each of the data points are. At the end of the day, if you don't do that, your data is going to be very fast and your algorithm will never have a way of connecting the dots together. So to make sure your machine learning model understands that, we're going to be using the standard scaler. It basically transforms and brings the data into a normal distribution. A normal distribution is a beautiful bell-like curve, as you might have seen. Now, what we are trying to do here is we are basically using support vector machines to quickly understand what's going on. And at the end of the day, you can actually use multiple kernels to work with it. Kernels and kernel functions are very, very important to how support vector machines work. We have a completely different course on support vector machines. If you guys want to watch that, where I've covered all of these kernels in depth. But here we're going to be using something called as the RBF kernel, radial basis function kernel. It's very popular, and all you have to know at this moment of time is where these two steps, if you're new into machine learning, if you're new into Python, I get always asked saying, hey, if I'm brand new to machine learning, which I've never used before, do I need 100 lines of code to just teach the machine learning model? Not really. This is when we call the process of model fitting, is basically when you're trying to take the data, provide the data to your model, and it is where it actually learns using the training data. This one step is where all your learning is actually happening. The next step is where all your prediction is happening. I told you, right? It'll train on the data. Later, we provided some brand new data to test it, to cross verify it. And all of that is done in two very simple steps. And to get to those steps is where you have to probably, use another 5-10 steps, right? Now, this is a very, very short demo, but at the end of the day, it will give you a powerful solution that you can take a look at. Now, this is something called as a confusion matrix. A confusion matrix will tell you if your machine learning model has the capability to predict all the situations correctly, right? It might so happen that in the real world, the person might not be diabetic, but your model says this person is diabetic. That is not correct. That's an incorrect case. Similarly, in the real world, he might not have diabetes, but you say, oh, with all the data that I have at hand, you have diabetes. He doesn't, right? So it's all a wrong case and a right case. So we have measures of accuracy here: true positives, false positives, true negatives, false negatives. And these 4 numbers in this matrix form, which is called the confusion matrix, is exactly what you are looking at, right? So having this very simple 2x2 matrix is going to give you a lot about understanding where, what is going wrong in your machine learning algorithm to basically fix it, eventually go back, perform hyperparameter tuning, come back, see what variables are there might be. Let me just go up to the data to maybe tell you about an outlier case. Maybe you see this person, right? This person has a salary of somewhere around 76,000. The person hasn't brought a product, but everyone maybe above 60 grand salary, they have all bought the product, or most of them have brought the product. Now, this can be an outlier case. Maybe removing this person's data can lead to extremely high accuracy, or removing it might crash your accuracy as well. You wouldn't know unless you actually tried, right? So that is where all the sensitivity analysis magic remains. The best part about this is something like a classification report. As you can see, you get a lot of metrics. Now, precision, recall, F1 score, support, all of these are very important metrics to tell you where your model is going wrong, where your model is going right. For all the zero cases, binary cases, you can figure out where your precision values are, recall values are. What is it for one? What is the level of accuracy as well? Macro averages, weighted averages. A lot of statistics, a lot of applied statistics. At the end of the day, having reports at hand to eventually start going back and to figure out what variables have what say on your outcome is the entire thing in discussion. I'm going to quickly zoom out. I know you might not be able to see the code, but I just want to clear the outputs as well to show you that, hey, this is a very small demo that we took a look at, right? A couple of lines at max. What is this, 20 lines? 20 lines is all it takes for us to actually go right from importing our data set all the way to us, basically predicting what's going on, and not just predicting, we're also printing the confusion matrix. We are printing the classification report. We have an understanding of why the model is behaving the way it does based on what parameters. And that is exactly what we're trying to do with sensitivity analysis as well, right? So this is a very, very small example using support vector machines to showcase to you guys about how you can work with that. Well, with that, we have actually come to the end of the course, guys. Thank you so much for watching. I hope everything I've covered is clear to all of you all. We started this out by going completely to the basics to understand what sensitivity analysis even is. We took multiple examples in each step of the way to make sure you guys are clear with sensitivity analysis. We understood what it is, where it is used, how it works, what are the various types of sensitivity analysis out there, local and global. We made sure to take a look at small examples. We made sure to clear up one common misconception is with respect to scenario analysis. So we quickly took up sensitivity analysis, we took up scenario analysis, and we cleared out that section to make sure you know what is what. And after that, again, at the end of the day, we took a look at understanding how all of these work in depth, and we also made sure to take a look at a demo where we've actually practically taken a look at understanding how variables can how these inputs, how these variables, or better, how these features can actually affect on your solution, and you can use the solution to get back and tweak and tune your algorithm to make sure it gets better. So not only in one step it is helping you, but right from data ingestion all the way to you giving results and you actually using that results efforts back to tune something, tweak something, and make it better, you see that sensitivity analysis actually fits well. And in fact, it is used. Again, we saw the applications, we saw the advantages and disadvantages as well. So now you know where it works, why it works really well, where it doesn't work so great, and why it might work or why it may or may not work in a couple of situations as well, right? So guys, with that, we have come to the end of the course. Again, thank you so much for watching. My name is Anirudh Rao, and I'll make sure to see you on the next one. Have a nice day.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.